Okay, here's the video notes for rate of change and slope. So I can find and interpret the rate of change and slopes of a line. These are the two standards that we're working in. Functions 6 and 5. Vocabulary. So this is important. Rate of change is how a quantity is changing with respect to another. And slope is the rate of change in the y-coordinate, the rise, corresponding to the x-coordinate, the run. So I'm sure you've heard this, rise over run. So let's take a look. Cooking, find the rate of change of the function by using 2 points from the table. So down here we have our formula. So rate of change is the change in y over the change in x. So now we just have to interpret what y and x are. So this is x and this is y. So I have to figure out how much this goes up. That goes up by 2. This goes up by 12. So now I put the 12, because that's y, over 2. I reduce, so it's 6. If I were to plot these points, remember this is 212, which is going to be up there. So, oops, need to change my color. So 212 is going to be up here. Oh, we can't even do this. 424 and then 36 is way off the graph. And we're going to have a line that comes down like that. So the amount of money Shamir earns Y after working X hours is shown in the table. Find the rate of change. So, once again, we need to remember our formula. This triangle means change. So change in Y over change in X. So how far do I go up? I go up by 4, and then I go up by 31. So I'm going to have my y 31 over 4. With rate of change, we can just go ahead and divide it. So you just take 31 divided by 4. And that's 7.75. Once again, we could graph this and we would have a line. So if we put this on a scale, we could go 8, let's say 62, and then 1293, and that once again is going to form a line. So Jackson High, the school student council budget varies based on the fundraising of the previous year. So now we're going to interpret rate of change from our graph. So we're going to find the rate of change from 2000 to 2005. So here's 2000 to 2005. So my X values, so change in X over change. Remember, I can change the triangles. So, oops, that's Y, that's X, my bad. Let's erase that. Start over. Change in Y over change in X. So X, 2000 to 2005 is 5 years. And then I have to do the change between 1675 and 1350, which is 325. I just divide those. So 325 divided by 5 is 65. So that is part A. Part B says from 2010 to 2015. So I'm going to change color. So from here to here. So once again, the change here is 5. And we're going down now, right? So this is going to be a negative number. So I'm going to have 1550 minus 1325. Oops. Which is 225. Negative 225 divided by 5 is a negative 45. And then we want to compare these. So we would just say that from 2002 to 2005, we were increasing by 65. And then between 2010 and 2015, we were decreasing by 45. So slope. Slope is the rise of run. So our equation's going to be y2 minus y1 over x2 minus x1. Don't let those subscripts get crazy on you. So what happens is you're just going to pick a point, and that's going to be y2 and y1. Because remember, our coordinates are in the form xy. So that just notates that you're using different points. So if we look here, our rise is already done for us. So we're going to take the negative 3 and the 1. So I'm going to take that y coordinate of both, subtract them, and I get negative 4. Then the run, I'm going to take the x coordinates of both, subtract them, and I get 5. And that is my slope, negative 4/5. I know my slope is going down, so this is a negative slope because I am going downhill. So we should know right now that this is a positive slope. So m, remember that's how we notate slope. We're going to take y2 minus y1 over x2 minus x1. So I just have to pull the numbers out. So I can take 7 minus 4 over 1 minus a negative 3. 7 minus 4 is 3. 1 minus a negative 3, which is plus, is 4. So our slope is 3/4. Once again, this one is going uphill, so it is positive. So this one's going downhill, so we know it's going to be negative. y2 minus y1, x2 minus x1. So I'm going to take my y's, 3 minus 1, negative 1 minus 4. 3 minus 1 is 2, negative 1 minus 4 is 5, and it's negative. So my slope is negative 2/5. So we're going to find the slope here. This is a straight line. Is there any rise or run here? Let's see. y2 minus y1 over x2 minus x1. So I have negative 5 minus a negative 5 over negative 2 minus 4. So remember, this becomes plus, so that's 0 over negative 6. Anything divided by 0 is 0. So this is a 0 slope. Whenever you have a straight line that goes horizontal like that, the slope is 0. So y2 minus y1 over x2 minus x1. So I'm going to take my y's, 4 minus a negative 2, And then my x is -3 minus a -3. So this is plus, so that's 6 over 0. What happens when you divide by 0? You can't, it's undefined. So when you have a vertical line like this, the slope is undefined because we cannot divide by 0. Find the value of r so that the line passing through -4, 5, and 4r has a slope of 3/4. So I'm just going to use my formula. So the slope, they already tell us, is 3/4. And then I'm going to take my y's. So I'm going to have 5 minus r, and then -4 minus 4. I'm going to simplify. So I have 3/4 equals 5 minus r over -8. Does this look like anything we've done before? Remember, when we have a proportion, we can do the cross product. So that's -24 equals 4 times 5 minus r. Just going to move that up here. So I'm going to distribute. That's 20 minus 4r equals -24. I'm going to subtract 20, and that gives me a -44 equals -4r. Divide by -4, divide by -4, and 11 equals r. So our point here is going to be 411. So here it asks, what's the slope at Cape Hatteras? So I just need to take my change in y over my change in x. So we'll do -2700 minus a -65, and we're going to divide it by 125 minus 75. So the x is 50, and -2635. I can go ahead and divide, and the slope is negative -52.7. We know it's negative because it's going downhill.